understanding about what are the methodologies which are applied for data analytics. So this would be the presentation that we will be discussing for another 1 hour from now. Before we get into data analytics, we can just have a visualization of the genesis of data. As I was telling, as I was trying to interact with you, the data was, the computers were used only in science and defense field once. Now it is applied, the processing is happening everywhere, and every minute the processing is happening, and the data is growing enormously. And the data has got three aspects into it. The first part of it is called as the raw and unorganized form of data. For example, you can say 24. When I say 24, all of what comes to our mind, 24 is a number, that's all. So the data type and the value of the number is in raw and unorganized format is called as the data. And when we add some context to the data, it becomes an information. So for example, this 24, what it could be. For example, if I say 24 is an age of a person, or 24 can be a door number, or 24 can be the mark secured by a person. So now when we add some kind of context to the data, it becomes a information. So after the information is stored, we can extract some knowledge based on the information which is already stored. For example, if I say 24 is a mark of a person, if in a specific subject, if I say this particular for this particular subject, if the passing minimum is 40, the knowledge that we can infer is the person has failed in that particular subject. Likewise, the data in the raw format can be added with some context. Finally, the context added with the data can be retrieved for future knowledge, maybe for decision to be taken at a later point of time. So the pyramidal structure of the data, uh, the threefold structure of the data, we have data, information, and the knowledge. And what exactly we are going to do with data analytics? We are going to play with the data. So what we are going to do, the data analytics is the process of inspecting the data. And when we have find that the data is not worth of using, when it has got some errors in it, some typographical errors or something like that, we can clean the data. When the data is not in a common standard, we can transform the data into a common standard. And when the data we have has to be visualized in in a particular pattern, we can visualize it, and we can model and store and preserve and analyze the data in a better aspect. So the basic of data analytics lies in the four important methodologies that are applied, or the techniques which are applied, called data cleaning, data transformation, data visualization, and data modeling. So the whole process of data analytics rests in these four components, or the techniques. And why do we need to do the data analytics? As I said, as we were trying to discuss just before, the enormous and exponential growth of data is a concern to us. When we leave this data just like that, the data may become unusable in the future. So to do that, we are doing the part of data analytics for discovering useful information among the pile of the data which is just lying on the cloud storage, which we have to clean, transform, visualize, and make it usable. And once we make it usable, we can make some conclusions based on the data, and we can use it for decision making. Just like as we were discussing about a small example, 24 is a mark of a person. When we perform a little bit of analytics in it, we can conclude that the person has failed. It's just a starting point. We can do much more than that. So once we make the data analytics in place, we can discover useful information, we can perform conclusions, and we can support decision making process. So what all about? In a nutshell, we can say data analytics is the transformation of the raw data into useful information, which we can turn it into knowledge. So I request all of you just to go through the pyramidal structure once again to recollect it. We can try to approach the process of data analytics once we understand these three terminologies: data, information, and knowledge. So when we have the raw data, we can add context to it to make it information into a meaningful information, and we can extract knowledge based on that. So this is a small introduction about what data analytics is all about. So we are trying to inspect the data, clean, transform, visualize, and model for transforming data into information and later some point of time into a knowledge. The whole context of data analytics lies in two dimensions. One is to ensure the quality of data using data cleansing and data transformation. We can do it, and also the same time we should also concern about the quantity of data, the huge amount of data which is being generated, and the quality of data, whether it is clean to use, whether it is timely, and the things and the parameters related to it. So we need to concern about the two dimensions of the quality of data as well as the quantity of data. And the next thing that we should know why this data analytics is needed. The data analytics is needed because we have huge amounts of data which is generated every second now. The moment of time now we are discussing over the internet, huge amount of data is generated in different formats. We are going to see what are the sources of data which is generated. So because of this wide availability of huge amounts of data, we have to analyze and make this data usable. So the catchword today would be make data clean and make it usable, and take decisions based on that. And once you have we are able to make it proper, you can use this data for variety of applications. And there is no limit to the number of applications of data analytics. Even today, in this situation of lockdown in the whole world and in the country, you can witness the data plays a significant role to analyze and to quickly uh, assess who are the quickly assess the symptom of different patients. And this is done based on the data which is collected over the period of time and by analyzing it. So it makes the process of diagnosing quicker and faster, and also more accurate than the past. So we are witnessing in day to day at this current scenario also. So the you can, after you analyze your data, you can make this data into a turn into a usable knowledge, and you can apply it for variety of applications like market analysis, fraud detection, customer retention, production control, and science exploration. And this is the concern now. The whole session is rooted on the generation, the huge and massive, we can say exponential growth of data. And this survey, I was able to collect it only up to 2018, and maybe it is becoming more nowadays. And in 1992, when the data generated per day was 100 GB, and now you can witness it is becoming 2.5 quintillion. And even this survey is not latest; it was done towards the end of 2018. So which means the data which is generated is growing enormously because of one reason. The reason is the usability of processing devices has turned from simple computers now to all Internet of Things devices, mobile devices, computers, laptops, tablets, smartphones. So because of that, the data analytics becomes more and more important in day-to-day life. To witness what this 2.5 quintillion of data may be equivalent to, it may be equivalent to 90 years of high definition video, to be precise. So you can imagine how huge the data size would be. Oh, and this is happening, this is possible because of the change of paradigm, computing paradigms from standalone computers later on into desktop computers and into client server computing. After that happened internet computing. After that we started mobile computing. And nowadays it is possible to have two types of computing which is happening all around the globe. One is the grid computing, and the concept of cloud computing, which makes the computers and the all the processing and storage devices connected in a virtual environment. which makes the almost the size of data that can be generated and the size of the capacity of memory device now we have is almost infinite, because we are accessible into the cloud storage where we can store almost infinite amount of data. No one know, and this is a pure virtual environment, which means we are not limited to the size of data which we can access and we can process. And the processing is complemented by the concept of grid computing, which is coming up. And this, because of these computing paradigms, the both the processing power is infinite and the data generated is also infinite. If you can just recall the people who are using the mail bro mail applications for over 15 to 20 years, when the uh, emails become commercial, were made commercial. The first one was Hotmail, and those time the capacity of mails that we can store in an inbox was limited, and now it is almost we can store infinite amount of data into our mailboxes. This is just a simple example and observation, which means that we can generate data in any format using any device and we can store it infinite. So that makes the next challenge into data analytics, and which is the form of big data, which makes the data infinite of size. So no one can estimate, though I said I shared with you a small size of data. It was estimated as 2.8 quintillions of data, but now it is becoming more and more, which means generated by different devices are almost infinite. And we can classify the data which is generated over the period of time into three categories. The first category is the structured, which we are, as computing professionals, we are used to it. We can store a data in a structured format using a database or a data warehouse. Usually, we store it in a database with different commercial database management systems. Then comes the semi-structured data. Structured data, if you have defined fields, the fields are all a particular, there will be a concrete structure to a database table. For example, if you create a database table, it will have some number of fields like roll number, name, gender, mark 1, mark 2, etc. So there will be a concrete structure for which I have to mandatorily feed data to all the fields in it. So there is a concrete structure which is called as a structured type. The second one is the semi-structured type, where we have a structure, but we are not bound to use uh, all the fields in the structure. For example, in an email, not all the fields are mandatory. Only the from, to, and the text may be mandatory. And what are all the optional fields may be the subject, the carbon copy field, the blind carbon copy field, and then the attachments. All these are all becoming all these can be optional. So in a semi-structured way of storing data, there will be a concrete structure, but you are not restricted to use the structure hard and fastly in all the occasions. You can have two examples for this. One is the email, another one is the XML. This is a kind of semi-structured data, how it comes into. Unstructured data or the streaming data, they come into the internet in the form of blog, tweet, etc. And this data, it does not fit into any standard format and becomes unstructured. And by this time, the type of streaming data which is happening around the internet is growing exponentially. And these three type of data may be the structured, semi-structured, and unstructured. Having a concrete structure, having a loose structure, and having no structure at all. These three types of data should be addressed. They should be analyzed properly to reveal the type of relationship and to make some mileage out of it. So this is the concern we are going to face it now. And how the big data is generating the data exponentially, it is because of one aspect is because of it is happening online. When you reserve a ticket, when you bill a particular product, and when you request something, when you do a transaction over your online mobile banking software, when you message someone, it is all happening instantly. And the smart devices which we have around us, the smart televisions, the smart ACs, whatever it will be, all these are generating data which are shared among them, and which is generated by Internet of Things. We know at present scenario the devices become smarter only because of the usage of data. For example, if I have installed an AC in my room, according to the temperature recorded over the period of time in my room for the previous month or previous week or previous day, according to the temperature in different points of time, the air conditioner can be programmed to change the temperature in my room automatically. So this is possible because of the sharing of data among the air conditioner with the temperature control device. And we are also generating data over our mobiles instantly in the form of Facebook, Twitter, YouTube, etc. and etc. And the other source of data which is generating massive amount of enormous amount of data is the health and scientific computing field. To put it in a nutshell, there are three aspects where we can generate the data into the inject the data into the cloud storage infinitely. One is the form of online, another one is the Internet of Things, the smart devices around us, and the mobile devices which we are using. And this is a very important and interesting slide that we have to look into. It is said that the data is the new oil. We know the Gulf countries became rich because of the oil that they have invented long before. Now, the data is available for all throughout the globe, which once you refine and properly utilize it, we can um, make better use of data, and which we can use by which we can better use it. The parameters of big data, most we might be knowing about it. This is the concern which makes the big data a different kind of a breed. There are five ways, as we know: volume, velocity, variety, veracity, and value. Volume is the size of data, the massive amount of data which is unpredictable. I cannot predict the data which is generated today and the data which is generated tomorrow. Even we cannot predict the data which is generated this second and the data which can be generated in the next second. It is all becoming huge and huge and huge. The volume, no, we cannot precisely predict. The velocity, the speed at which the data is generated, it is like we cannot always predict the speed of the wind all the time because it varies. The velocity of data which is generated over the internet is also like a wind, which the velocity cannot be estimated, which makes it the second important parameter of big data and the second challenge that is placed before us. And the third parameter is the variety. The variety, the data, as I told you, the data which is generated is not in a single format. It is not from a single place. It is in different varieties. And when we scientifically approach, we can say the data can be coming into three flavors: structured, unstructured, and semi-structured. That is a variety of data which is being generated. The veracity, whether the data which we have at hand is accurate or timely. That is what we can look into in this parameter called as veracity. The value, uh, the timeliness of data is the value of the data. The data which we have procured after the time in which it has to be used becomes useless data. So there are five ways that we need to consider: the huge amount of data, the volume of data that we have, the speed of data unpredictable called as velocity, the structured, unstructured, and semi-structured, the different types of data that we have in hand, the variety, the accuracy of data, the veracity, the timeliness of the data, which is the value. The based on this five parameters of data, we have a lot of applications of big data. Actually, we are trying to look into the data analytics part, which as we were discussing before, the whole crux of data analytics lies in four techniques: data cleansing, data transformation, data visualization, and data modeling. And all this rests in the quality and quantity of data. So the quantity of data is what we are trying to look into the dimension of big data. So we can have a small look into what are all the big data applications. And what we should not forget is the amount of data which is generated is infinite, and the speed is unknown, and it is generated by multiple devices, not only by the computers. It is also generated by the computers, mobile devices, the smart devices around us, the internet of things, and things like that. And the big data applications, we have transaction databases, the recommender systems. We know about it. For example, if I'm just keying in, I'm right now located in a place called as Krishnagiri in Tamil Nadu. So if I want to buy a two-wheeler, if I type for example, if I type Honda Activa, immediately I get a response, say from Google, saying that Honda Activa, the price and other details. But what comes on top of my search is a little interesting. That will show the list of Honda showrooms around me. I never asked for it. I never asked for it, but it recommends me about the list of Honda showrooms around me in Krishnagiri, which means that this is possible by collecting information about me, about my browsing history, and about my location, and about my search actually. So precisely, it is able to tell me what are all the Honda Activa showrooms around my place. So which means the transaction databases can be used for this kind of big data applications. And wireless sensor data, the smart home facilities, as we are discussing, the air conditioner can be programmed to change the temperature around it based on the data it is collecting about the temperature, which is the next application of big data. And the product review and customer satisfaction, which happens in social media. And in the COVID lockdown, the social media is the utmost is the maximum used application nowadays, which is generating huge data now. So which means which is the next variation to it. And we also have the application of software log data, and which stores all the log information about a software. And for example, if my if my Windows software is having some corruption, automatically it is troubleshooted based on my previous user history. And it is also widely used in genotype and phenotype data, which is applied in the field of healthcare application. And with this, what we have gone through so far, what we have gone through is the data analytics is very much needed because of the exponential of growth of data, and we need to concern about the quality of data and quantity of data. So what we can do is we can take the data, add a context to it to make it information, and we can extract the information to make it knowledge for later use. And the data which is generated in different aspects, as we were trying to look into. It can happen over the internet, it can happen over IoT, it can happen over it can be generated because of our mobile devices. And the quantity of data is based on the big data applications. And what we were trying to see is about some basics about the big data applications that we have in place. And now let us try to look into the four important techniques that are applied in data analytics, called as the data cleaning, data transformation, data visualization, and data modeling. And to before we just proceed in, and nowadays we can apply data analytics in every field of computer science. maybe in software engineering, maybe in data structures, whatever field you can apply data analytics. And it becomes there are a lot of techniques which are already being developed. And for example, there are a lot of algorithms which are in place now. We can apply all these algorithms, and we can also conceive our own algorithms. We can tailor the existing algorithms, and we can also try to perfect it. And to implement the algorithms becomes very simple because of the usage of two languages widely used. One is the R language, another one is the Python. And both these languages have got plenty of plugins, plenty of libraries which can help us instantly to play with the data almost. And whenever we say about the data quality aspect or the data analytics aspect, we cannot do that without a little bit of statistical application. And uh, and all these packages being installed in R and Python, they are used for uh, statistical observations. And we need to have some kind of understanding about basic statistics, not as a statistician, not to the maximum extent. A very simple statistics like how to calculate mean, mode, average, standard deviation, variance, things of that sort. So that is the basics to all kind of data analytics. And we have powerful packages installed in R and Python, where we can do this kind of transformations and cleaning within minutes or within seconds of time, and with only with a few limited lines of code it is possible. We can learn it, and there are a lot of tools available online to go and learn about R and Python. But what is important as a computer professional, as a computer scientist, or as a researcher, or a scholar, or as a student, is just to know what are the four important techniques which are applied in the process of data analytics. And the first type is data cleaning. It is the data cleaning is called in different names, called as data cleansing, data cleaning, data scrubbing. All are same, and it is simply detect, you correct and remove the inaccurate data. It is not only a record. You can detect, correct, and you can rectify your inaccuracy in the data which you have already captured. And you can do it from a record or a table or a database, uh, which makes this data cleaning more appropriate for directly applicable for a structured data which is already existing. And why do we perform data cleaning is to identify the incomplete data we have, the incorrect data we have, and inaccurate data we have. We can identify, for example, incomplete data. You have an address field. In the address field, everything is there excepting the door number, which makes it incomplete. We can identify that kind of record. The incorrect record, maybe the record with a suspicious entry may be incorrect. Inaccurate, maybe, for example, if I want to store a mark, if I am not validating it, if I have a mark like 150, if my maximum mark is only 100, it is definitely inaccurate. And what we can do after we find out what are the incomplete, what are the corrupted data which we have already stored, what we can do is we can perform these three activities to either rectify it or to simply detect or to correct it. You can replace, you can modify, or you can delete the data which is coarse, or the technical term used for that is the dirty data. Dirty data is the data which is having some kind of errors in it. So this is the process of data cleaning. And how we can perform data cleaning, I like to give you some examples about data cleaning. And this process is not a new area altogether. It is what we are trying to do in our database design in normalization, and steps after that uh, is the first phase of data cleaning. And to enforce data cleaning in our data, we can confirm the constraints. Once you enforce the constraints strictly into a database, we can ensure that the data is almost clean. And how we can do that? For example, so to make our data clean, the primitive step is to ensure these constraints. You can ensure the type of data. For example, if I have a mark field, I should make it as integer. So which means that that is the first type of enforcement. I can make sure that I will not type inaccurate data like a alphabet into it. And the range constraint, if you are specifically saying you are going to enter a mark, you can specify the range of the field. For example, the range of the field can be 0 to 100 to ensure that I cannot enter a negative mark, or I cannot go beyond 100 to make it perfect, so that the data will not become corrupted or dirty by inaccurate data. And you can enforce mandatory constraints, so which makes your data to be protected from this incomplete data. So I can make my data prevent my data becoming incomplete, incorrect, or inaccurate using all these type of constraints. And unique hello hello unique constraints, I can ensure that the data again it is not becoming incomplete. And
Participants, please put off your mic, please. Don't share anything except
hello.
the speaker. Others can please put off your mic and video. Don't share your screen, sir. Sir, continue, sir.
Okay, thank you, sir. And the next one is the set membership constraint. For example, if I have a field to make it perfect, I can have a kind of values from a set. For example, if it is a gender, male, female, or transgender, that could be the membership constraint. The foreign key constraint across the table, if I want to make sure that the data should be conforming to a standard, I can do it. And the regular expression patterns, for example, the vehicle number, I can have some pattern like TN24 99 XX 9999 that follows a pattern. So only the vehicle number throughout the country would be the first would be the first two alphabets will be used for identifying the state. For example, MH for Maharashtra, KL for Kerala, TN for Tamil Nadu, and we can have that pattern fixed, and followed by the district RTO vehicle registration number 24 is for Krishnagiri, and followed by two dots, which where we can ensure that only two numbers are entered, followed by two alphabets are entered, followed by four numbers. And the cross-field validation refers to if I store the mark of a student in 5 subjects, mark 1, mark 2, mark 3, mark 4, and mark 5, the total field should have a constraint saying that it should not exceed 500 for totaling all the 5 marks. This is done to make your data avoiding to fall becoming corrupt or dirty or codes, avoid your data becoming incomplete, inaccurate, or incorrect. So this is the first step. We do it in database design, which we are doing it over the period of time. And the second one is you can implement consistency. To put it very simple, consistency is to enforce that something is being followed in all the places across the system. Inconsistency occurs when two data items contradict with each other in two different places. A very simple example, you can have two different addresses for the same customer, and only one of them can be correct, which means that you can have a consistency among the data which you are storing in two different places. We can also have another example in due course of time. And uniformity refers to a very simple observation is, for example, if I am storing a mark of a student, the mark of a student can be a numeric data. In most of the colleges and universities, we store the mark as a numeric data from ranging from 0 to 100. And somehow in some of the universities and colleges, they are also using a grading system instead of marking system. The grade can be A, B, C, F, G, and the letter grades differ from place to place. D for distinction, F for fail, and P for pass, and M for things like that. It doesn't matter. So which means that the data which I am storing in one place should be of the same nature in another place. For example, if I am trying to have a system that connects with all the universities across the country, all the universities may not follow the numeric marking or a grade based marking. So which means that I have to transform the data, or I have to make the data from one format to another format. If it is a number, I have to make it a numeric field in all the places. If it is going to be a grading system, I have to make sure it is a grading system in all the places. And the example that I have shown here is, for example, if you are storing the weight of a person, the British system is pound and the American system is kilo. You can either follow the pound or kilo, and you have to ensure that any one of this is being used. And there are another three aspects of data cleaning which we can do. One is the parsing, what we have seen as the pattern based. Parser will be a string of data which can be accepted within a particular field. For example, the vehicle number in Tamil Nadu, I can write a small parsing string which can be like TN 99 AA 9999, where TN is common, so I cannot change it. Instead of 99, I can enter two numbers to identify the RTO office where I am registering my vehicle, followed by two alphabets, followed by four numbers for identifying the vehicle. So when you enter a vehicle like TN AA, it will not be accepted, because TN should be followed by two numbers, two alphabets, four numbers. So this, if I am fixing it inside a field, the parser will ensure that only the data of this kind will be entered, which makes your data always perfect and always fit for use. And one important aspect of data cleaning is called as duplicate elimination. Technically, it is called as data deduplication process. And this data deduplication can happen in three ways. One is in file level, and block level, and in field level. For example, we can just have some understanding about what is file level duplication and what is field level duplication. File level duplication is very simple. This is happening, and we are all prone to this kind of duplication in all our day-to-day life. For example, the presentation I am presenting to you, I have the same presentation in three places. One is in my laptop, another one is in my mobile, another copy I have saved in Google Drives. The exact copy of the same file is duplicated in three different places. Just imagine if the file is a simple PPT, it may not occupy a lot of space, but if it is going to be a movie or a audio video file, it occupies lots of space. And if you are multiplying the number of times you are storing it in a storage device, duplicating it across your storage devices makes it duplicate, and which is sitting in different places without any use. This is the file level duplication that can happen. And what is field level duplication? The same field without any purpose, you are trying to store the information in across 2-3 different tables. The same field, for example, the name, if you are not properly normalized, you will be storing the same name of a customer in 2-3 tables without any without conforming to the standard, which means it is going to be a duplicate in terms of in terms of field. And there is another kind of duplication called as block level duplication, which will happen inside our internal memory. It is enough for us to know about file and field level duplication. And there are a variety of methods used for eliminating the duplicate copies. One method is a simple method is done using hashing. You know what is hashing? You will generate a unique hash value for a file, and if you find the same value in another file, you can consider the files as duplicates and you can remove the duplicate copy. But the problem here is, if you have a very simple change in the file itself, a new hash value will be generated, which will consider the files as two independent files rather than duplicates. So a lot of research is going in this field of eliminating duplicates among files and as well as among fields in data cleaning. And the statistics is playing a vital role in understand in doing the data analytics part. And for example, you can try to make use of the mean, average, or standard deviation range procedures to to find the relationships among the table that you have, the data that you have, and to remove the unwanted data from your place. For example, what I can do, if I am storing my um, marks of students in a university, I'm just saying for an example, we need not store all the marks of a student till the end. Instead, what we can do, after some 5 to 10 years, instead of storing the whole data, we can just compute the average marks of a student and we can place it somewhere. I'm just saying it an example. It may not find sense or make sense also. Just I'm saying, instead of storing the 5 marks of a student in a subject, after some point of time, I can just make it as an average of all the subjects, and I can store a single value for future use. That can be a simple statistic method that I can do. And this standard deviation and variance plays a vital role in identifying the data which may be suspicious. For example, just consider I have secured these marks in my 5 subjects. Maybe my marks are 20, 30, 20, 30, and 80. And if I say this is my mark in 5 subject, 20, 30, 20, 30, and 80, immediately as a teacher, as a faculty, you can have a query in your mind. That is, the student is not intelligent. He is an average student or below average. He has secured only 20 and 30 in 4 subjects, 20 in 2 subjects, 30 in 2 subjects, but he has secured 80 in 1 subject. Definitely, it will catch our eyes. That data may be suspicious. That data has to be cleaned. Maybe it may be correct also. So what we have to do, when we do a kind of a variance test among these 5 data, 20, 30, 20, 30 with 80, 80 will be significantly deviating from the core data 20 and 30, which means that 80 may be a suspicious data. It may be or may not be. Only we are observing the data is suspicious because it is deviating heavily from a common value, which we can do it very well efficiently using the clustering algorithms. There are a lot of clustering algorithms which are used for grouping the data into clusters, and the data which is deviating from a cluster may be suspicious data which may be catching our eyes, and we can use it for rectifying it. And the clustering algorithms, there are a lot of there are different types of clustering algorithms. The origin is k-means clustering. All the clustering algorithms are based on the statistical based methods, and the clustering is unsupervised way of cleaning your data or grouping your data, and the opposite of it is called as data classification, which is grouping the data in a using a supervised mechanism. So kindly note down all these catchwords. When you see data cleaning, it is a starting point where you can make your data clean and accurate for later use. We can use it by enforcing our constraints into the database, by implementing consistency, following uniformity, and by performing parsing. And more importantly, we can do it using 3 important techniques called as data deduplication, data clustering, and data classification. And each of these is a wide field, interesting fields which we can explore. A lot of researchers are going in these 3 areas right now because of the huge demand for pure data and for data analytics. Only because of these recent times, R and Python are becoming quite popular. The first kind of data analytic technique is over, which is data cleaning. The next to follow is the data transformation. And what I am trying to share with you is just an introduction about what we can do to understand about data analytics by having my own examples or the which I have gathered over my past experiences, just to ensure that you can understand. This group may be a varied group where people may be already working in the field of data analytics or novice to the field. I'm just trying to put across my opinion about how you can start your career in data analytics field. All these catchwords you can, if you are pursuing research or if you want to pursue research in the future, you can have this catchword just to have a kind of understanding about data analytics, and it will definitely help you in the future process. And that's because I'm trying to put some things simply as I know. Thank you. And the second type is the data transformation technique, where we can simply to put it, we convert data from one format to another format. The year 2000 was rememberable to all of us because of one problem called as Y2K. People sensed it long before, but that Y2K problem, we know why it happened and things like that. Just remember about that particular Y2K problem. And now, what is data transformation is? Data transformation is converting data from one format to another format. Not simply converting from one to another, but of enforcing a common format in all the places. If you follow a format, for example, if I follow a parameter for storing my distance, the parameter, the unit of measurement is kilometer, I should be always storing it as the kilometer. If I'm using the parameter unit as mile, I should be storing it always in a mile. One field, I should not be storing it in a miles, and another table I should not be storing the distance in kilometers. Definitely, it will put the system in hang mode. And to understand this, we can try to look into the two different types of date styles that we are accustomed to. One is the British style, another one is American style. And if you have the British format, which we use it in our day-to-day life, we write the date in day, month, year format. The Americans, they write the date in month, day, and year format. So if you follow the British format, you follow that strictly, or American format, you follow it strictly uh, across the databases that we are storing the date values. And this is the starting point of data conversion. So data transformation is converting data from one format to another format. And how do we do it? Convert data types, cleanse the data by removing the null values or duplicate data, enrich the data, and perform data aggregations to transform the data. And why we do the data transformation is because of this guidelines which are given to us. One is, you have to make your data compatible with another data source. I have a university which is trying to uh, build a database of its students across the colleges. Each college is following its own format of storing the students' date of birth. Each college is following different format, in the sense we have to make the date format to follow a common format or pattern, either DDMMYY format or MMDDYY format, and you have to make that particular data compatible over all the other data. This is a simple example. And you have to transform the data because of this compatibility issue. And number two, you have to move the data from one place to another place. If I am trying to move my data from a database to a collective data warehouse, again this compatibility issue will arise, where the data may not conform to a common pattern. You have to make sure that the data is transformed into a common pattern. Number two. Number three, you have to combine your unstructured data or streaming data with a structured data. Very challenging situation. A lot of research is going in this area. And though we have three kinds of data formats, like structured, unstructured, and semi-structured, now at present, what is catching the eyes of researcher is the type of the techniques for handling or analyzing the streaming data or unstructured data, because this streaming or unstructured data is now almost contributing 80% of data which is generated per day. The other kind of data is not that much generated, because now we have moved into the new digital era, where we are performing mobile computing, or we are performing IoT computing, which makes this very important. So you have to combine you have to deploy your mobile app or your desktop your internet application or whatever it may be, to be compatible with your unstructured data, which makes the data to be transformed. The need for data transformation very important. And another one is you have to add information into the data to make it more enriched by adding geolocation data or timestamps to it. Finally, to perform aggregations, as we were trying to have a look into it, over the period of time, you can aggregate the data rather than storing all the information. You can aggregate the data, and you can make sure that the data is not stored completely. Rather, only a summary of the data is being stored. Like you can try to store the average of all the values or the maximum of the values or minimum of values and things like that. So these 5 points, you have to make your data compatible, you have to move the data, you have to combine your structured data and semi-structured data with unstructured one, you have to add more information to the data to enrich it, you have to perform aggregations, making the process of data transformation very important. And how we can perform data transformation? You can try to perform data transformation in three stages. One is perform data discovery to identify the sources of your data and data types. We are trying to have a common data warehouse for students biodata in a university. So across your colleges, you identify what are the different colleges available, what are the sources of information from those colleges, and what are the data types they are trying to store for storing a biodata. Especially, we have taken an example of DOB, the date of birth field, how they are using. So you perform data discovery based on this step number one. Step number two, determine the structure. You have to find a common structure. You have to design your own structure, maybe whatever is applicable for you based on your previous understanding. Maybe what format may fit your place, may fit your data warehouse, maybe DDMMYY format or other formats. We have to do it in stage number two. Stage number three, after doing it, you have to make all the databases into a single stroke. What you have to do is you have to perform the data mapping using you take all the database tables, all the fields, and pull out all the date of birth fields of all your all your constituent colleges, and you perform this mapping, which you can see. The date field should be mapped with the date field, the month field should be mapped with the month field, and the year field should be mapped with the year field. So data transformation is purely done. The keyword for data transformation is compatibility. And compatibility is trying to ensure all the database tables, all the data are following the same standard. And how do we do it? It's a three-step process. Perform data discovery, determine the structure, and perform data mapping. And we have the data transformation methods in place. We can do it using scripting, and you can use SQL scripting or Python. Even in our language, you can do it. On-premise ETL tools, extract, transform, and load tools are available. Cloud-based ETL tools are available. You can make use of all these types of data transformation products which are available already, or methodologies to transform your data. So, just to have a glimpse of what we are trying to do now, we have started with what is data analytics, and data analytics is resting on converting data into information and turning it into knowledge. And for doing this, we are trying to use 4 different methodologies. One is data cleaning, the second one is data transformation, third one is data visualization, finally data modeling. All the four techniques we are speaking, we are discussing are independent techniques which we can use one after another to uh, perform data analytics. And the platform we can apply, maybe or Python we can apply for doing all these things. And the catchword in data cleaning was data cleaning constraints, the uniform standards, the parsers, and the way of data deduplication, data classification, and data clustering. And the catchword for data transformation is compatibility, and the 3 stages of data transformation to make different data into a common platform. And the third technique is the data visualization, which makes all the data to be better looked into, to have a better insight about what you have in place. you can distill large data set into visual graphics so that I can try to understand the impact of the data in one place. For example, you have this situation of COVID-19 now. The government has already uh, classified certain segments as green, orange, and red sectors. How it is done is based on the number of COVID-19 cases which are recorded in a particular place. So if you say, if you go to the official website of Government of India, and the official website will say the Indian map will be displayed, and in the Indian map, the sectors you can see it as red, green, red, orange, or uh, uh, red, green, or orange sectors. This is done by gathering the number of patients in that particular area and visualizing it. And this is a better way of visualizing the impact of COVID in across the country. So, for example, if you say in a particular state, if you see the state map completely in red color, almost in red color, the visualization tells you that the state is completely impacted by COVID virus. That is the visualization. That is the strength of visualization. Rather than if you just display the state map with some numbers, it may not be appropriate. But always visualization is better for human brains to understand, grasp things faster. Why we have to perform data visualization is you can have an improved insight of data. You can have a improved insight of data, and you can have a fast decision making. For example, if the union minister is sitting for a discussion, easily by looking at the map of India, a state is completely red in color, the union minister can easily you can decide, and you can make stronger decisions for that particular state to have the conditions clarified. So improved insight, faster decision aids in faster decision making, better understanding of data, and identify the trends or patterns in the data. We can easily visualize it with the current scenario by making a particular visualization of a data. It gives us more insight to the data. You can have a faster decision making, and you can have a better understanding of data, and you can identify the trends or patterns in the data quite easily. And the advantages of data visualization, this slide will help you. Simple example I'm trying to present to you. Some kind of devices and sales happening in a particular electronic showroom. Then the type of devices and the sales in numbers in units are displayed. This table, and on the right side we can see the pie chart, which is describing or visualizing the same data. By looking at the pie chart, it is very easy for us to visualize. One particular segment is very large, one segment is very small. You can say what is the maximum sales and what is the minimum sales, what is the average sales, and things like that very easily. Instead of looking into the table monotonously and trying to grasp the thing, I can easily say what is the trend in my sales by looking at this pie chart. So immediately next month I have to procure more air coolers and procure very less iron boxes. So that is the scenario or pattern I can visualize in this particular example. So this is a simple example, and data visualization can do much more than that. There are a lot of tools available. We are going to have some tools. We are going to see the names of some tools, and we are already using the tools. And most of the tools are uh, not or open source tools. You can use it free of charge, which can improve the insight of our data. And not only in field of data analytics, you can apply this kind of visualization technique in all the types of researches you do, so to derive better results about your experiments. If you are experimenting, to present your experiments in a better way, you can apply all these data visualization techniques according to the context of your research, which can improve the experiments and research that you are experiments and outcomes results you are trying to project in your research. There are four type of visualization methods, not only four, important four we are trying to see. The basic charts, the bar, pie, gauge charts, that we can display the data in visualization. We can visualize the data. The map, the tree map, the word cloud, the Gantt chart, all these are types of maps. You can use it. Histograms, the uniform histograms, the bimodal, the symmetric histograms, we can use it. the plottings, the scatter plots and box plots we can use for data visualization. To have better understanding about data visualization, you can get into the concept of data mining, where data visualization is a very major role, very major step in data mining. Also, data analytics is the next stage of data mining, we can say, and data visualization plays a vital role in both data mining and data analytics. There are a lot of data visualization tools available, and when I was just browsing through the net, I found that these 5 tools are used in most of the places: Tableau, Quick Click View, Fusion Charts, Data Wrapper, and High Charts. There are a lot of visualization tools, and why data visualization is done is can be understood by this slide. Instead of pure and boring text, if you have visualization graphics, you can gather, and human brain can gather things much faster to have an improved insight of data, to decide faster and to understand the data faster and to identify the trends or patterns. So this chart gives me an improved insight about my sales, and to have a better understanding about my sales and to decide faster that in the next month I have to procure more lesser iron boxes and more air coolers. And the final concept of the technique of data analytics is the concept of data modeling. And data modeling is not a new concept to us at all. As like data cleaning, data visualization, and this one, as we see, have seen in data visualization, data cleansing, and data modeling is not a new field to us. It is what we are already doing it. And we have started modeling our data when we started drawing our first ER diagram, entity relationship diagram, data flow diagram. And that is the primitive way of modeling our data. And when you have a strong structure for your data, though I say the unstructured data and semi-structured data are coming in more into pictures, the data modeling helps us to turn unstructured streamed data into a structured model, to bring it into a structured model. Only when you bring it into a structured model, we'll be able to analyze and make decisions out of it, and it will give us a scientific method for accessing and storing and retrieving our data. So though we have a unstructured or streaming data which is coming across, I have to convert it into a structured type, and data modeling can help us to achieve it. And data structure is a way of storing data in a computer so that it can be used efficiently. It's simply an organization of concepts of data, and the very basic preliminary stage that we have already encountered is the modeling of entity relationship diagram and modeling of data flow diagram in our softwares. There are plenty of data modeling methodologies which are already existing, starting from the flat model, hierarchical model, network model, relational model, star schema, and data vault model. And we are accustomed to this relational model where we can where we can have this combination of DFDs, and we can normalize our data to have a perfect data model for our system. And we are approaching the end of our session today. The data modeling, the keyword is you can model your data to make it a structured data, whatever the type may be, even if it is a structured or unstructured, or if it is going to be a semi-structured one, you can make it as a structured data. Understand the data, then you model the data, validate the model, build the model, deploy the model. These stages are what we exactly do it in the stages of normalization, along with the help of the tech tools called as ER and DFDs. And nowadays you can we are using UMLs and uniform modeling language for automating the process. So my dear participants who are listening to my session now, It all what I wanted to convey to you is my little experience over past years about data analytics. In fact, my research area is in data science, which is more precisely in data classification. I have done a small research on it. My PhD thesis was based on data clustering methodology. So based on my little understanding about the subject, I'm trying to convey my insights over data analytics. So to just go through, to rush through what we have seen today, we started with the concept of data analytics, the pyramidal structure of data analytics, which is the raw data, which can be transformed into information, which can be turned into a knowledge in the future. And to do this transformation of data into information, which we can use it for future knowledge extraction, we are trying to apply four concepts or four techniques. The technique number one is called as data cleansing, data transformation, data visualization, data modeling. Data cleaning is to make your data usable. And to make your data usable, we have enforcing the constraints, and we are trying to apply the concept of data deduplication, data clustering, or data classification. And data transformation is performed to enforce compatibility of data across different streams, and that is done in three-stage process, and we have tools for doing it. And data visualization tools are used for providing better insight about our data, to have a visual representation of data, so that we can take quick decisions, and we had an example for that also, and there are tools for doing it. Finally, the data modeling will help us to follow a series of steps that will make our unstructured and semi-structured data into a more concrete structured format, so that we can perform scientific uh, algorithms on it to access and analyze the data in a efficient manner. So this is what I wanted to uh, share with you with my little understanding about on data modeling. And thanks for your listening. I think we can have some kind of query session now for another 10 minutes of time if you have any queries, and then we can stop the session today.
Uh, what is it?
Thank you, sir.
Thank you, sir. Thank you.
Participants have any queries? So, Judge, sir.
Yes, I'm listening to you.
Yeah, the question was raised by chat box.
Okay, okay, okay.
What are the concepts of data cleaning and data mining?
Actually, data mining, it was a starting point, and data cleaning later was emerged, so that we can have some kind of clean data which can be used. So, which means that data mining and data cleaning are related to each other. And how do we do it is using some simple statistical observation.
Okay, sir. So another question:
Yeah.
how can you ensure data quality?
Ensuring data quality is done mainly it is done using the kind of four techniques that I have gone through today, and especially it is done using the concept of data cleaning and data transformation. There are procedures for that.
Other
And one more question, sir.
Yes, yes.
The difference between data mining and data pruning.
Data pruning. Actually, all these keywords the participants are asking to me. All these are related with the concept of data quality assurance, especially in data analytics.
Okay, sir.
Accurate or not. Data cleaning is enforcing that.
data
Sir,
analytics.
sir,
Sir,
actually, what is data pruning?
Hello.
Exactly, what is data pruning, sir?
Data pruning is finding out whether the data I have in hand is usable or not.
Okay, sir.
Thank you.
So another
Sometimes,
question:
yeah.
list out some tools of analytics.
Data analytics tools, as I was sharing with my slide, I may be sharing the slide with you. You can have a go through it. I am not able to remember it now.
Okay, sir. So the question from Chintu Chandran sir,
yeah.
difference between data visualization and data analytics.
Difference between?
Data visualization and data analytics.
Actually, data visualization is a technique used for data analytics. Data visualization helps us to visualize the data in a better way. That's it.
Thank you, sir.
What
Okay.
are the tools we can use on a cloud-based ETL?
Madam, actually, in my slide, I have listed out some of the tools that we can apply. Maybe I can share it with you, with all the
So
participants.
please
You
share
can...
the slides if possible on the.
Pardon, madam?
So please share the slides on the.
Yeah. Definitely, I will share. Also, I will try to include some more names of the tools you can use. Definitely, I will do it. Don't worry. And when you see the tools and techniques, what we were discussing today are the primitive techniques, or the preliminary and the base techniques that we are applying. The tools and the online products which are available, the free source tools which are available, they are emerging plenty. We can choose our own tools according to the type of research we are performing now. Okay, shall we wind up now?
Yes, sir.
Okay, I thank all the participants for your active participation. I will share my slide with the coordinator. The last slide, I will add my official mail address, my private mail address. If you have any queries, you can ask me, and I will try to clarify your doubts. So once again, I thank all of you for your patient listening. Can we
Sir,
wind up now?
just a minute, sir.
Yeah.
Just a minute, sir.
Yes.
George, sir.
Yes,
Sir,
sir. I'm
George Origis, sir, coordinator, sir.
Yes, sir. Yes, sir. Tell me.
Please convey the session on tomorrow regarding
Yes.
tomorrow's session.
Okay. Good afternoon, dear participants and delegates. Tomorrow we'll have a session in the morning at 10:30. The link will be shared around 6 o'clock. Tomorrow the feedback link will be given for you for today and tomorrow session. So kindly fill up the feedback link, and then we will provide certificate tomorrow through your email. After completion of your feedback link, which we have provided to you, you complete it and you get the certificate. All of you, if you have any query, we have text in the WhatsApp group. Thank you, sir.
Tomorrow is last day, no? Tomorrow is last day.
Yes, sir. Tomorrow is the last day of the session for the 5 days TV program. So I would like to thank our guest speaker, Dr. George Lewis, the Secretary College, on behalf of the management and on behalf of the BCA faculty. Wholeheartedly thank you, sir. Thank you very much.
Thank you, sir. Thank you. We can sign off. Thank you. Bye. Thanks.
Thank you. Hello, sir. Thank you, sir. Shall we wind up?
Okay, sir. Thank you, sir.
Thank you.
So, George, sir, thank you, sir.
Thank you, Balamurugan, sir. Okay.
Okay, sir. Okay, sir. Thank you, participants.
Thank you.
We'll see you on tomorrow.
Oh, sure.
Some has got their so they should avoid